Okay, I think we can go ahead and get started. It's just about 5 o'clock. Tonight, I want to show you how to make changes to the three sample SQL files that were on my website that you should have downloaded. The ddl.sql, dml.sql, and report.sql. These three files will house all the code for your database that you're going to build, the database and the tables and inserting data, updating data, deleting data, and then reporting are in all these three files. And these three files are the ones that you have to embed in your Word document and then also attach as a separate attachment when you upload your IP3. You should be uploading 4 files. So we'll start. I'm in SQL Server. If you don't have SQL Server and you need to modify them using a text editor, once you download the zip file and extract the 3 files from there, so someplace on your computer, you can right click and say open with, and then pick whatever text editor your system might have. I don't know what it is for a Mac computer. On Windows machines, you can do Notepad. And you can right click, open with Notepad, and it will open it as a text file, and you can make the necessary changes to update these files so that they match your database, your retail store name, and then all the tables that are in your ER diagram. In SQL Server, you simply go to File, Open, pick File, and then navigate to your network location or your computer, wherever you have the file saved. You can single click and then control click on the other 2 and open all 3 of them at the same time. And they'll open up just like they did in mine with a separate tab at the top for each file. When the file shows a little asterisk on it like this one does, it shows that there was a change to this file that hasn't been saved yet. So that's good to note. So this file hasn't been changed at all. So there's no asterisk, and this one hasn't been changed yet. But you'll see this asterisk as soon as we make changes to this other 2 files, the asterisk will appear. That prompts you to save your changes before you close it. But even if you go to close the file, it'll ask you if you want to save changes before you close. So we'll talk about this first part of code, this section up here, which is where we're going to use this code to actually create your database within the SQL Server environment. Yours might look a little different than mine because I have 2 versions of SQL Server installed on my computer. This one is the newest one. This one is the version prior. So the database, there's a system database called master that you can see over here in this Object Explorer. If you hit the plus signs, you can expand things, right? You can expand that, look at the tables in there, system tables. It'll show you everything that's in there. And if you expand the tables, it then shows you attributes about that table. And you can view your column names that are in that table. And we'll show this as we work on our database, how this comes in really handy when you're doing your insert statements and updates. But the master database has a table called databases that controls all of the databases installed in this instance of SQL Server. So we need to create our database so that we can actually work with it. If I were to try to create all this stuff here, it would create it in the database you're connected to, which is this master database. So this code, the use statement tells SQL Server, I want to switch to this database, and it makes it the active database that you're currently working against. This statement just simply says, if in this database table, in this database main master, there is one called CS660 demo, I want you to drop it. And then this statement will create the database again. And then this database, the use statement, switches to the active database so that you can switch to your database now once you've created it, so that all this other code that you run against the database will be executed within your database. So I have comments in the code, right? So change the name to your store, no spaces, but you can use underscores. I'm going to just use CS660 demo, but change this name in every place you see it to whatever the name of your store is, or whatever you want to call your database. Just don't leave it the same as what I have. So you would have to change it on this page in 3 locations. This part here, this one here, this one here, and then this one down here. 4 places, sorry. So update that. I run code in segments. So I'm going to highlight the sections of the code that I want to run first. I want to do the look and see if it's already there. If it is there, drop it. If it's not, and then recreate my database in the master database system. So that way we'll execute that statement. It'll run, show you at the bottom that's executing the query. It shouldn't take that long to run, but Probably because I was, hold on, let me go up. You go back up here to master. Okay, use master. Let's try it again. Because we see the database exists. It usually doesn't take this long to run. It usually runs fairly quickly. Let's try it. Oh, because I was currently attached. I had the database open, so that's why I didn't do that. But our database exists. So when you run it the first time, it'll create your database, and then it should. I'm not being, unless I have it master and master. Okay, I'm not actually using it, so this should drop it. But it thinks it's in use for some strange reason. And I'm not using it. Okay, let's do this. So I have some databases in my other version. Here, I'm going to close these files. I'm going to do them in the other instance of SQL Server that I have installed. File. Now open. File. ELDNL. So it opens them all. I'm back on this one. This one shouldn't exist. See that's more like it. It runs a lot quicker. It runs fairly quickly. So now if I were to go over here, anytime you run code in the code window, it doesn't automatically update or refresh your Object Explorer. You have to refresh it manually. So if you click on databases and hit the refresh button up here, you'll now see there's my database. But this scene up here shows you the available databases that I'm still currently logged into the master database because I haven't run this use statement yet. So if I execute this, the name of the database will change right there. Shows you it completed successfully. And now I'm working in my database that I created up here. So then we're going to go through and you can use this code and just modify it to fit your database, right? Whatever you called your customer table, just change the name of it here. Add your fields and then your data type and then your null or not null. And then for the first one, it's the primary key. We have to indicate primary key. So I built my table with customer ID, customer first name, last name, address 1, address 2, city, state, zip code, phone, and email. I figure that's a good subset of data that I can capture for my customers in case I mail them things or I need to contact them by phone or email. I have all that information in the database. You'll notice I make my primary key field is an integer, data type int. All of my other fields are variable character fields. I use variable characters because of the way it saves data in the database. A character field, I could have made these char 75. I use varchar because then it saves data in the database depending on how much data you actually enter. So if we make this field char 75, when it writes to that column in the database, it's going to occupy exactly 75 characters of space. Variable character is only going to occupy enough space, the space depending on how much you actually entered for that particular field in that column, in that row. So if I only enter 20 characters, it'll only occupy space in the database for 20 characters. So I find that a little bit more efficient on the database itself. So create table is this is the format for create table statement, right? You have create table, you have the name of your table, you have an opening paren, then you list your fields, data type, then not null primary key. You separate every line with a comma, except for the last line. You don't put a comma after the last line, and then you close it with a closing paren and a semicolon. So if I actually highlight this code and click the run button or execute up here, it'll execute. It'll switch to messages and tell me that it completed successfully. But you'll notice if I click on tables, I should see this one. This one I see customer tables because I hadn't had the tables expanded if I had it expanded when I created it, it wouldn't show me. I would have to just refresh. But there's my customer tables. I just put some additional code down here. The 2 dashes represents a comment in SQL, as well as the /* for the beginning of a comment or */ for the end of a comment. This way you can comment out multiple lines instead of putting dashes in front of them. So if you have like 10 lines of comments, you can separate them with this one. It does it a lot more efficient. This one here, the 2 dashes is still a comment. So that if I were to highlight this code and highlight these, if I highlight this, SQL Server ignores it and it won't run anything because it's a comment. It knows it's a comment because it has the dashes in front of it.
Professor, I have a question.
Yeah.
On the data types, sir, when I was doing research, a lot of the SQL code that I've seen has varchar 255. I did not see any of these data types. What do you recommend?
Well, varchar is the actual data type. The number inside the parentheses is the actual size of the field.
Okay, so we
That's,
can make it arbitrary.
yes. I mean, for a first name, you probably shouldn't need more than probably not even more. You don't need 75 probably, right?
Okay.
That's kind of long.
Yes.
Um, for an address one field, 55 might be good. You can play around with it. Just think like the city names. Some city names could be really long, so I made that one relatively large. So the size just depends on the data you're capturing. So I mean, first name, but using varchar, if I put varchar 75 and I only enter 30, it's only going to occupy a space for 30 in the table, right? But you
Mhm.
can't put any more than 75 because then you'll get an error message telling you that it's going to truncate it. So
Okay.
I just arbitrarily picked numbers, what I thought was good for the size of the field for the data that I was inserting.
Thank you. That answers my question.
Like for state, I only put 2 because I'm going to use the state abbreviation instead of spelling the state out. So we just do it that way. So yeah, I see that a lot too. Varchar 255 is like a default size for a text field in a Microsoft Access database. So if they create a table from an Access database table and it's set to a text field, 255 is the max for a text field in Access. So that could be why they're all 255, or they just want to make sure they don't get any truncate issues. So,
Got you. Thank you, sir.
all right. I have some SQL statements here. You can highlight those and run them. It won't do anything yet because there's no data in our table if we just select everything from it. If I realize like, oh, I want to change the size of a field. First, I can't just change this code and run it because I'll get an error message because the table already exists. I have to drop the table. So I'm going to do that. I'm going to drop my customer table. I go over here and refresh my database. My customer table is now gone. I'm going to change this last name field to only 155 characters. And then I can just highlight that code again and run it. And it will run successfully. If I click on my tables over here and hit the refresh button up here, it'll now show me my database table. This statement, truncate tables, and this delete from tables, those actually perform the same action. They remove the data from the table, but they don't affect the table structure like drop table does. So if you populate it with data and you need to make changes to the data, or you want to change the data, just truncate it or delete everything from the table. That'll clear all the contents. Then you can make changes to your data insert in your insert statements. You can change your data if you need to. So I just put these 4 here. I use those occasionally when I'm working on databases, and I have them, I think, below most of the queries. If not, you can just duplicate those and just change the name of the tables. I have them here for orders. My order table. So here's my order table. Again, my primary key field is an integer. I make them all the same data type, so it's consistent across all my tables. That way I really don't need to think about it. I know I make them as an integer. I don't have to keep, especially when you're inserting data as primary keys and foreign keys. If you keep the data type the same, then you won't have any problems. Order date fields. Notice for the date fields, we don't specify a size because there's a specific format for dates in SQL. We have our order total because we have to do some calculations as part of our reporting, right? So order total, this one's a decimal. These numbers tell me that it is 11 digits is a precision. And this is the number of digits to the right of the decimal point. So actuality, I have 9 to the left and 2 to the right. So if you're making, make sure you make your fields large enough, right, to hold your dollar totals. And then again, this one here, I have a comment after it here showing it's a foreign key field for my customer ID. So I can link my customers to my order table. The way that they set it up with only giving you an order table, customer order, and a product table, in that scenario, you can only ever have one item on any order for a customer because the order ID cannot be duplicated So you would have to generate multiple orders for a customer if they wanted to order more than one product. So to fix that problem, I throw in this table, an order line table. And that helps me control all of the orders and the products because the order line ID can be different. We don't care. You can duplicate the order ID multiple times. If the customer wants to order 5 things on the same order, the order ID can be the same. You would then have different product IDs for all the 5 different products they're ordering, but you won't get any key violation errors doing it this way. So this order line ID just will increment by 1 every time. I put the item price here. Again, I made that a decimal. Notice my foreign key data types are the same as my primary key data types. So that way it's consistent. They're all the same. You can make those characters if you want to make them all character. You can make them varchar if you want. You can make them integers. Just try to keep them consistently the same across all of your tables. This one's a decimal, so it has a total of 7 digits. So there's 5 to the left, and then there's 2 to the right. And then my item quantity is an integer because they're going to order one. They're not going to order 1.5 of something, right? Or 1.25 or something. They're going to order a whole number. So I just made it an integer, make it easy. And then again, I have those same old queries there. If you want to see what's in the table after you populate it, you can run that one. If you need to drop it for some reason, let's drop that. I didn't run this one, did I? Did I run the order table? I don't think so. I'm going to highlight this. I'm going to highlight all this code. Notice that this comment is highlighted. It won't execute it because it is a comment. It knows it by the double dashes. If I hit execute, it just tells me that it completed successfully. I come back to my tables over here and hit the refresh button. I'll now see my order line and my order table that I just created. But I figured I want to increase the size of my item price. So I'm going to drop the order line table by running this, highlighting that code and running it. So notice you can, even though it's commented out, you can still highlight it and run the code. It'll still execute. If you were to run the whole page, it would just ignore it. Just highlight the portion of the line that is not the comment indicator, right? So you don't highlight these 2 dashes or that won't run. But if you highlight everything to the right of that, it will run. So now this table is gone, right? No order line table. I'm going to increase this to 9 and then rerun my create table statement. It completed successfully. Again, this, you always have to refresh this if you want to see anything in the screen. And then there's my table. So we do that process for all of the tables that you have on your ER diagram. You can use the product order and customer tables I have here. Just change the fields to match your ER diagram. If you feel you want to add more fields to it, you can add some fields like I have here and leave it the same. I don't really care. We have to do our product table. Again, primary key is an integer. This is for product description. I made it a varchar max. That lets me enter a whole lot of information. If I don't know how big a description I'm going to enter, I can enter a book inside here. If I wanted to, I wouldn't probably enter that much data, but I can enter a paragraph worth of data if I needed to for the product description because I made it a varchar max. Cost is a decimal, 9 total. So 7 to the left, 2 to the right. Reorder quantity is an integer. So when I hit whatever my threshold is, 25 or something, I know it's time for me to reorder it. I have a couple of foreign keys in this table, manufacturing ID and a category ID. To make it simple, I could have just put the category in this table, but I wanted to add another table so that I could join it again and show you how to create another table. So I created this product table. I can highlight this code and execute. It will run. I come back over here. I can refresh and see it. There it is. Here's my categories table. I'd have a cat ID, which is again is an integer for the primary key. Notice we're not doing any foreign key designations in these tables. I'll show you down at the bottom of the code where I do alter table statements. This is easier for beginning students to just create the tables with the primary key and then add the foreign key to it after you insert the data, so you don't actually get any foreign key constraints if you don't enter the data in the correct order. Having those foreign keys in place, you have to then systematically enter the data in the correct order so that the system knows where those foreign key values are and that they already exist. If the foreign key value is not in the database in the field where it acts as the primary key, you'll get an error message. So it won't. So I make it really easy for you. We'll do that part after we do our insert statements. But then I have a category, a description, and a title. because I think one of our queries is total of something by category. I can't remember exactly, we'll be on here when we get there, but you need a category. So either put a category in your product table or create another table with categories if you want. You can use this code for that. I execute it, it completes successfully. And then this is my manufacturer table that I link up here to my product table. I'm just keeping track of all the manufacturers for all the products that my store sells. And I just name the fields. I give the fields a name because I have a lot of name and address fields in my database. I know exactly which one is. If I just named it address 1 and address 2, then if I see the results, I won't know necessarily what address that is. So I give it a name that kind of makes sense with the data that I'm actually loading into it. So I'll execute that. It's successful. Here's another way you could do customer addresses if you wanted to. I created a table for customer addresses because a customer might have maybe multiple addresses like you can on Amazon, right? You go to Amazon, you want to ship it to, you pick an address you want to ship to. So maybe I have 5 different addresses in there. This lets me do that. Linking to the customer table by the customer ID. I can have as many addresses for each customer as they want me to have. I just put the state ID in here to show how to do another foreign key field to another table that I created for states where I have a state ID, state abbreviation, state name, just for demonstration purposes. You don't necessarily do it that way, but some places, if you have states, it might have Canadian provinces in it or whatever. So, and they have abbreviations for those. So that might be a good idea that way. And then you can just link to this table with the state ID or whatever state it is. Let me see if I've done my manufacturing table. Let me see if I refresh this. Yes, my manufacturing table is created. I'm just going to create these just so we have them in the database. So now if I go over here and refresh, I can see now I have successfully created all of my tables. Common mistakes I see are, let me drop customer address table. Common mistakes. Just drop that so I can run it again and show you. So common mistakes are leaving off commas. Notice when I took that comma out, the next line shows a red squiggly. It has an incorrect syntax. So if you're using SQL Server, it'll key you if you have syntax errors, if you're missing some. So if you see something like that, just take a quick look above it to see if there's an issue. Because if I try to run this code, it's going to give me an error message. Incorrect syntax, near city. The good thing about SQL Server, you double click on the error, it takes you right to the line it says the error is at. So then I can see, well, that line looks good. Oh, the line above it, I forgot to put the comma. So you have to put the comma in. I think it'll let you actually run it, I think, with the comma at the end, but you don't need the comma on the last line. I think they got smart. Yeah, it lets you run it with the comma on the last line. So if you forget to take the comma off the last line, it'll still execute and create your table. So now we have all of our tables in our database over here that we can see. We'll come back to this part after we do our insert statement. So are there any questions from anybody on the create table statement? Or data types or any of that stuff that we covered up here? I know, Ronald, you missed the beginning. I showed how to actually create the database using this code, which is in the sample files. So this, the use statements tell SQL Server what database you want to make the active database that you're working on. So by doing use master, there's a system database in here, which is called master, which keeps track of all the other databases you created in your instance of SQL Server. So you have to switch to that one first. And then we're looking in this table here for whatever my name of my database is, whether the name equals this. And I have some notes here, right? Change it to the name of your store. If you have any questions, no spaces, but you can use underscores like I did. And then change this name, and then you have to change it here, here, and here. Once you do that, then I would highlight this code I'm not going to execute it because it'll dump my database and get rid of all my tables I just created. So, but if you execute this code, it'll create your database, and then this another use statement here, run that code. It switches to the act, makes that database your active one, where you can now run all of your code to create all your tables. Make sense?
Makes sense.
All right, awesome. Do you have any questions on the create table statements, or?
I'm gonna go ahead and review the video from the beginning after
Okay.
it's all done.
Okay. Good deal. So that's creating the database and then creating all the tables. And also your table names shouldn't have spaces in them for ease of reporting, because theoretically you can put spaces if you enclose them in square brackets. Customers, I call that's a legal table name and has a space in it. But then every time you report, you use this, you have to enclose it in brackets. It's just easier to not use brackets and just use underscores for the table names if you need to. Or not tables. Some people name your table as TBL to know that it's a table. I've got used to that format using Microsoft Access. I always name tables that way because you can look and see them easier. However you named them, but just don't put spaces in the names. So now we'll, again, it's got an asterisk up here. Let me save my code. I'm going to save it. So it'll save that file. I'm going to switch to the DML file. You'll notice there's two different formats for ways to insert data into the database. Again, at the top of every page, you have to switch to your database, because notice up here, this is the active database in this window up here. It's set on master because that's the database that was in focus when I opened the files. So if I were to just run this code, I think, let me see, this one doesn't, make sure this one doesn't have a table in it. Oh, it does have a customer table. It would actually insert, because by not changing it, I did this on purpose, by not changing this and running this code, it's going to insert it into this table, into this database, and this is not where we want it. So I got to drop all those tables. We don't want the tables in our master database. We want them in our database that we just took all that time to create. So if you highlight that statement, you can execute it. It'll switch the active database name up here to on the top to your database. And it has that same thing on the report file. The very top line is a use statement. So you can tell it, hey, switch to my database because I don't want to do all the work in the wrong one. Because then you might get, if you created your tables in the correct one, but then you try to insert data into it while you're in master, then you'll get error messages saying the table doesn't exist. And you're like, well, I know it does because I just built it. So just make sure that this always has the name of the database that you're currently in. Our insert into statement this is the format, insert into, the name of the table. I remember online last night I showed you can list all the field names after the table name if you want to. You don't necessarily need to. If you don't, and we don't really need to do that, but you can if you want. But we're going to insert data into every column and every field that we put into our table. So you don't need to. So by default, it's going to expect me to have data inserted into every single column that I built on my table over here. This is where this comes in handy. So you can expand the customers and the columns so you can see all of the columns you have. Right? I have all this and this, these are in the exact order that I built the database table in. So inserting the values has to be in this same order if you're not going to list them up here at the top. But theoretically, you could put up an opening paren and then you could put it in whatever order you wanted to, right? You could do email first, you could do cust ID second, and then insert the data in that same order, however you list it. But we're not going to do that. I'm just going to leave it the way I have it. Because I'm inserting my customer ID as a primary key field, right? It's an integer. So you notice it's not enclosed in single quotes. We have everything else is a varchar. So I have now every single other field is enclosed in single quotes and comma separated in this list. I have a couple of fields I allow null values to be entered into. I have address to, and I have email, which I allow null values for. This one here, right, has an address to. I put that address to here. And I showed you how to insert. So if you don't list, right, you have to specify null for columns that are nullable. So that will be the essence of not actually having any data in there. If you do closed, not double quotes, single quotes. You do single quotes, it would insert an empty string into that field, and it's not the same as null. So for any field that you have null, if you don't have data, enter the word null, like I did here. And then I did it for the rest of these for address 2. And then I added an address 2 for this one, and this one's null. You can, so depending however you build your table, insert your data in the same order like you have here, with making sure you're noticing what your data types were. And then if you highlight, and again, comma separated list, right? Everything's separated by commas here, except for the last line, which has a semicolon. I can highlight all this code and hit the execute button, and it tells me how many rows were actually affected and how many were actually inserted. So if I want to see my data, I can run this little handy thing down here at the bottom. I have a select statement here, so I can actually see the data that I just inserted. Execute shows me all of my data. There's my address 12. That's a null for all these records. Then an address 2, and then null again. A couple of nulls I inserted there. So I can see, okay, my data is inserted correctly. And this order table, this format is this is just a different way to do the same thing we just did up here. It's just you doing insert into the table name and then values, and then you're inserting one row at a time with another insert into statement and a value. I don't know, whichever one you find easier. This is a little bit cleaner to look at than this, but if you want to use this way, that's fine. Whichever way works best for you. So then my order table. Okay, so I'm going to expand my orders over here so I can see my fields. Okay, I have order ID, order date, total, and customer ID. Okay, order ID. Notice that this order ID, of course, is an integer. Notice this one up here started with a 1. So 1,000. Any 1,000 number that I see, I know is going to be a customer ID. Any 2,000 number I see is going to be an order ID. So on and so forth. And I made product IDs 5,000. I made categories 6,000. I made manufacturers 7,000. Order line I made 3,000. So just as a visual reference to myself, I know when I see that number what that number represents. We're going to insert. It says invalid, and this is the funky thing about SQL. Sometimes it gets strange. I don't know why it's showing me invalid object name orders when I see my table right here. And it will let me run this code even though it has a squiggly line on there telling me that it's wrong when I know it's not wrong. My value, again, here's my date. Here's your date format, right? Month, day, year, separated by a slash for date fields. That's how we enter dates. This is my order total, my decimal, is 11.2. So 11, I have only 3.2. And then this is a customer ID. So notice my customer ID 1025 is already in the database table. And it must be in there, which is one of the reasons why we run the alter table statements afterwards, to prevent you from having to remember to enter the data in the correct order. Because if I put my foreign key constraint in place now, before I did this, and I tried to maybe do the order table first, right, it would give me an error message saying that this value, a foreign key constraint value, this doesn't exist in the database. It has to be in the table where it is the primary key field in order for you to use it. So if we do that afterwards, you won't get any of errors, and you can insert data in any order you want. Just make sure that your values match. So I'm going to highlight all my orders. Remember, I said you want 20 in customers. I didn't do 20, but I did 25. And then orders, you need 20, and products, try to enter 20. But the rest of your tables, just enter any arbitrary number that you feel makes sense for you. Okay. We're going to execute that. And then see how this one differently, one row, it shows you the different rows because they're all different statements, insert into statements. This one showed me just a total number. This one showed me for every row that I inserted. So whichever format works best for you, that's fine. My order line table is just essentially a bunch of foreign keys, order ID, product ID. Those are my foreign keys. And then I have item price and quantity. So here's my order line ID. Then 2,000 was my order IDs, 5,000 my products, so that I know looking at this what those represent. And then this is my item price, and then they bought 3 of them. So then you can do some calculations when you're doing some queries, some reporting. You can do calculations if you want to get a total. You would take the 3 times that to give me my order total, and then add that together, and you get all your sums. So you can do some aggregate functions like that. So we're going to insert into this table. It should tell me 4 rows. Yep, 4 rows affected. Product tables. This one has the product description. I didn't enter a whole lot of information, but I can enter a whole lot more than that. Because I made that field a varchar max. And then this 20 is what? Reorder quantity, then manufacturer matches my 7 down here. And the 6,000 is my, that's category 6, 7 is manufacturer. So then manufacturer ID, if I move those around and I had my foreign key constraint in place, I would get an error message. But since I haven't done that yet, I can just highlight this and run execute. It shows me for all the rows that were affected. And then we'll just do this for our categories, manufacturers. And notice I'm highlighting comments, but they won't run because I have them commented out. So it ignores those and then inserts my other data into my table. So now all my tables should be populated with data, I think. Any questions on the insert into statements that you might have? Okay, we'll go on to the update. We're going to do some updates and then some delete statements. You have to do, they tell you to do, I think they give you 3 of them to do, and you have to add 3 more. Whatever the project requirements say, I can't remember off the top of my head, but this first one, we're going to update this table customers. We're going to set the city. I want to change the city to Tempe and a zip code to this number for this particular customer. So if I go here, so customer 1007, if I run this first to see, I can look at my data right here, 1007. Right now that person's in Phoenix and it's 85083 is their zip code. So after I update this record, it shows you that it completed. I can run my statement again just to do a visual check and make sure that it's right. 107. There, it updated to Tempe and updated to 85089. Now, if I were to, let me see, I'll do this one first. Customers, I'm going to change this address to apartment. Oh, that, because this person doesn't have an address too, right? It's empty. It's null. So I'm going to actually give them an address too, apartment 123. Run that code again. Apartment 123. The hazards of not using a where clause, if I were to just highlight this code, if I didn't have this, this was my query I run. So now when I run this, it updated 26 rows. It updated every single record and made every person move from Phoenix. We all now live in Tempe, Arizona. So that's the power of SQL and the hazard of not using a where clause, especially on update statements and delete statements. And then this one's just updating. It's going to change the product cost for product 5005. 5005, the product cost right now is $234.55. I'm going to update that cost. I'm going to set it to $567. It runs okay. Highlight that. Oh, I don't want new queries. Oh, wrong button. Got click happy there. There's my price update. You can see that it updated. These are just a couple of delete statements. You can use these, change the table names if you want. This declares this one, this comment doesn't even make any sense. It's not right, but ignore that. Beginning a transaction, I'm going to delete customers where customer ID is 1006, and then I'm going to commit the transaction to the database. It removed it. So if I select everything from my customer table, I now do not have a customer 1006, 15107. It deleted it from the database. And then this just essentially saying, I don't think I have a, do I have a? Yeah, I have a. This is another transaction. I'm going to delete from products. And this just has some error handling and a rollback included into it if I get an error message for some reason. But it deleted 3 products from my product table. If I select product, so now I only have 6 rows. I deleted the ones that had that, whatever that description was, recliner as my project description. So those are the updates. You just had to do a couple of updates based on, right, these primary key fields. Those are important. You can do the same ones I did if you have customers, IDs or whatever, or tables or products, however you're going to do that. And then just do a couple of deletes and you should be good. Save my file. It has an asterisk on it. That means I made changes to it. I'm going to save it so that I don't lose anything. And then finally, we have our reporting. Again, there's my use statement. I already ran it, so I'm in the correct database. All this code at the top here, all this does is sets us up. This code sets us up till we have a table with some data in it to do our crosstab query, which is one of the required queries. You can just leave this code in here, just update some of this data, right? So I want to update, I'm going to change 2020 to 2023, I think. So you can do, I can highlight, I can do a control F. It'll bring it up with that in there. If you hit the drop down thing, I can now use this and do a replace, a find and replace. So it highlights all of the ones that it found when I did that control F find. And I'm going to change that to 2023. And then if I push this button, replace all, it's going to update all those rows, all those records are now 2023. I want to change 2021 to 2022. It tells me that it replaced. So now I have my data. So now if I highlight, this does exactly the same thing we did in the beginning, right? It looks to see if there's a table in there called crosstab. If there is, it drops it. If there isn't, it will create it right here. And then we're going to just insert some records into it. So if you just update the years, that's fine. And then just highlight the insert statement, run it. It'll insert all that data into your table. And then this is the actual crosstab query right here. We did all that setup at the top so that this query would work correctly. You don't need to change anything in this unless you want to try to, because you can create a crosstab from your order table since you have a date in there. But if you just want to make it simple on yourself, just leave this the way that it is, highlight it and run, and then that's what the crosstab looks like. It's essentially a pivot table. These I entered in the three basic queries that you have to do. Total revenue sales per month group by customer, total revenue sales group per month by product, and then I did a count of orders by customer. This one I threw in a little join to show you. Well, this one has a join too, to show you how to do joins if you want. If you don't want to join and you want to make it as simple as yourself as you can, just remove the joins and then select it from whatever tables you want to. But there's 3 of them here, and you have to add 3 more. So this first one is total revenue sales per month group by customer. So I have to have my customer ID so that I can group it by customer to begin with. And I need to get my date because I need to do it by month. And I'm going to need whatever my sales dollar amount is, order total. I'm going to need that so that I can do an aggregate function on that total, right? So I'm selecting from the orders table, and remember my orders table has customer ID in it because I use that to join to the customer table. So I have my customer ID, so now I can do it and group it by customer. This date part function allows you to extract parts from your date fields because we have our order date, right, which was month, day, year. This, we want to do it by month. So date part is a built-in function. The interval, if you do search it up, you can look online. It'll should explain what the different intervals are. There's month, DD, YY, or YYYY for year, from whatever field you want to extract it from. So I have an order date field in my order customer. That's the field I need to get the month out of. So I use my date part function. I tell it I want the month. I put comma, the field I want to use, and then I'm going to give it an alias, give it a name. So I'm going to call it order month. And then here's my aggregate function we talked about yesterday, right? This is a sum, and I had my order total. So if you don't have a total order total someplace in your order table, you probably want to add one so that you can complete this query. Then I call it as total revenue using the as alias for my customer table. Now remember, since I have some fields in here that are not part of my aggregate function, I have to group my whole query by those. So I have my customer ID, and then I have my date part here, as part of my group by clause so that I can include the order date in my group by because it's not part of an aggregate function. It has to be included. And then I'm just going to order it by customer ID. So if I highlight that and execute that query, then until it returns it, right? If I want to do it in descending order, DESC keyword, so it'll do it in reverse order by customer ID. You can do it by customer ID, or you can do it by date, part, order, month if you want to group them by month. So now it's 4 and then 11. If you had customers like this customer 105 has it in 11 and in 4 they have some orders, so we can do multiple groupings, right? We can order by cust ID first and then the order month, so that it will give me my customers grouped by customer in the correct order. So now I have 1005 here, and then by order month, so I get the earliest month first, and I can see that what their total is by month. And then we're doing the same thing essentially here with revenues per month grouped by product. So my products, this one, I have my order line table. If you don't have an order line table, you can do from your order table or your product table, I think. But they want to know revenue sales by product. So your product table should be linked somehow to your order table. So you need that product ID. I did mine as a join because I had that order line table that I added in there, right? I gave all these tables an alias, as you can see here. To make it easier up here, I only have to reference it by the alias instead of the whole table name. Remember, my order line table had item price and item quantity. I'm performing this calculation. I'm multiplying the quantity by the price, and then I'm taking a sum of that calculation. So that'll give me my total revenue. Again, the date part, month by order date as order month, same that it was up there, so that I can group this sales, get the sales per month group by product, and then I just include my product ID. Again, the left join, so this on tells me which fields in these two tables that are establishing that join, right? So in the O table, orders, it's going to be my primary key field, which is my order ID. In my order line table, it's going to be that foreign key field I added for order ID. Notice I keep the names the same to make it easier. They don't necessarily need to be the same names. And I work in many databases where they're not, but for our purposes, if we keep the names the same in the different tables, it makes it a little bit easier. And then I'm just grouping it by my alias, product ID, and then my date part again. So if you highlight that code and run it, it shows you product IDs by month. So if you add data, if you make the data a little bit different in your product tables or your order table, different months, you'll get some different outputs and you'll be able to see it a little bit clearer. Mine all has the same order month. So that's why it's like that. And then this one is just simply a count. I'm just doing a count aggregate function of order dates for a number of orders by customer because I included my customer ID. Notice here, I didn't use an alias for the orders table. So I have to identify customer ID by including the table name, because that field customer ID exists also in my customer table, which I did use an alias for here. If I didn't do that, it would give me an ambiguous column name, and then I would have to specify that. So let me see if I take this off. It should tell me ambiguous column name, I believe. Yeah, ambiguous column name, cust ID. And I double click on the error, it takes me right to the spot. So I have to preface that with the table name or the table alias, since it exists in both places. And then you just need to come up with 3 of your own. You can do some more counts if you want, or some different sums or mins or maxes, whatever. Any 3 of the 5. We have 5 aggregate functions we talked about last night. Any of those you can use, and just add 3 more queries. So I know that's a whole lot for one night, but we do have it recorded, so you can watch it over and over again if you need to. Any questions on any of the reporting or the insert stuff or updates or anything we covered tonight?
No, sir.
Okay.
Professor, I do have one question. I know you went over it last night. So can you just briefly let us know exactly? I know you want a DDL from us, a DML SQL, and then how many reports is it?
There's 3 they give you, and you have to add 3 more. So there's 6 total reports, but 6 total reports, but one of them has to be a cross tab. So you only have to really make up 2 more.
Okay.
So you have these 3, which are the 3 I think that they asked for, and then this cross tab, which is one of the ones they tell you one of your additional ones has to be a cross tab, but
Okay.
that's already in there. So you have that. So you just have to make up 2 more aggregate function queries for your reporting. And then that's it. That's don't forget to attach the files. If you start working on it and you have any questions, please IM me or send me a message or email me your code if you're having questions, or if you need screenshots of errors you're getting or whatever it is. Reach out and I'll try to respond as quickly as I can. I usually try to keep on top of that now that I have my the CTU app on my phone working correctly, where it actually gives me notifications when I get messages from students. And I usually respond right away as soon as I get those, so that you can continue working. So I hope that was helpful. And if you have any questions, let me know.
So you said there's a video on how to attach these files to the Word document.
I think I did one on embed, but you know what? Since you're here, let me show you really quick. It's fairly simple. Let me start a new share. Let me open up Word. Oh, I have my file I'm working on open, so I'll just share that one. Share screen, Word. Where is it? Okay. Don't mind my. Okay, you should be able to see Microsoft Word. Yes.
Yes, sir.
Okay. Yeah. So in Word, if you need to embed files, right, you click wherever you want to embed them. Let me make this a little bit bigger so we can see all the stuff on the menu up here. And then we go to the insert menu, right? And then on the insert menu, there's one called object. If you click on object, it'll open up another little window for us, which tells us we need to either create a new object from something or attach an object from a file. And that's what we're going to do. We're going to create it from a file. We're going to hit the browse button. You're going to navigate to wherever you're on your computer you have the code saved. Unfortunately, you can't do multiple ones at the same time, so you'll have to repeat this step 3 times. Right? So I'm going to select my DDL. I'm going to select insert. I'm going to link to file and display as an icon. So that will show this little icon in your Word document for this file that I'm attaching. You can change the icon if you want to, but you can just leave it to whatever comes up. That's fine. And once you hit OK, it will now just show this. Now this file is embedded. So if you'll see at the bottom, it says double click or double tap to activate contents OLE package. So if I double click on this, it's going to prompt me to open it. So then I can open the file and you know that the embedding worked correctly. And then you just repeat that process for your other 2 files. Object, create from file, browse. Of course, it doesn't remember where it was. DML, link to file, display as icon. Okay.
Excellent. Thank you, sir.
All right, fairly simple process, but if you haven't done it before, I've worked in Word for many, many years, so I'm familiar with how to use this very well. I've written a lot of papers in my time, and I'm working on one now, a discussion post for a class I'm taking. All right, that's it. If you have any questions, let me know. If not, I hope you have a wonderful evening, what's left of it, and a great weekend.
Thank you, sir.
Thank you very much.